In this video, we are going to see the program solution for binary search in an array sorted in ascending order. Right? So here are a few considerations that I must say before I begin with the code part of this video. The input array that we will take from the user will be sorted from before, but that may not be the case in the question that is asked in your exam. In the exam, you may be asked that you need to perform binary search on an unsorted array. Now, if you were asked something like that, the first thing that you should do is you should sort the array after taking it as input, and then you must apply binary search on it, because you know binary search would not work unless the array is sorted. And here I'm going to show you the code for binary search on an array sorted in ascending order. For an array sorted in descending order, some things in the code would change. A few lines in the code would change. Well, to name, just 2 lines in the code would do the trick. All right, let's get on with it. So our class name begins out to be gibberish, and I'm going to delete everything and start with the import statement. Import java.util.scanner, and I'm going to name the class binary search, and that will be upper camel case. Next, the first thing we need to do is take input in the array. I'm going to create a function for that. Next, display elements in the array. Number 3, to search for an element using, this needs to be a comment, using search method. All right, let's address this one by one. First, we take input in the array. So void put in ARR. I'm going to demonstrate it on integer array. All right. So I'm going to create an object of the scanner class. System.in. Then we will need a loop that's going to run from 0 to the length of the array -1 plus plus. Next, we're going to tell the user to enter the element at position -1. This is the prompt. Enter element plus bracket I plus 1, and arri equals a seed of next int. It's done. Next, display elements in the array. So void display arr. We're going to need a loop, and I'm going to display the elements in the array comma separated. Right. So for int I equals 0, I less than equals arr.length -1 and plus plus, and then I'm going to need a system.out.print statement, and there are I plus comma, right? And then put a system.out.println below. All right. Okay. Now to the objective of this particular video. Next, we're going to write our binary search method. Now this method is going to return the position of the key found in the array. And if the key is not found in the array, then we are going to return -1. And because the index has a type of int, therefore the return type of this function would be int and would be called binary search and written in lower camel case. It would take in the array as input and the key. All right. Now we need some variables. So LV, it starts out as 0. UV, that would start out as n-1, where n is the length of this array. Now we know the length of the array in Java is arr.length and then it would be -1, pos would be -1. Okay, so our initialization has been done. Then we need to write a loop while LB is less than or equal to UB. We continue our search till LB does not exceed UB, because if it does, then it violates their definitions, right? And next, we're going to calculate the index of the middle element. So that's LB plus UB by 2. By 2. Okay. Now that that's done, one of the three things can happen. Number one, key element lies in the left half. Number two, key element lies in the right half, or key element is the middle element. Is found. So we need to address these three situations. So if the key element lies in the left half of the array, then the key element must be less than the middle element of the array. So ARR mid. Now be a little careful over here. I've seen students make the mistake of writing mid instead of ARR mid. Remember, key is an element, right? Therefore, we must compare an element with another element. So the element at the mid position is ARR mid. Mid is not the element, mind you. ARR mid is the middle element. Okay, so please don't make this mistake. I've seen I've seen students make this mistake plenty of times. Therefore, I'm warning you. Please don't do that. All right. Now, if if the element lies in the left half, then we must adjust our upper bound of the array, because our upper bound changes, right? Our lower bound would still remain at the starting position of the array. So UB would be set to mid -1. Now, next situation that would occur is if the element lies in the right half. And how can that be checked? That can be checked if key element is greater than the middle element. Again, we need to check the key element with the middle element and not the middle index. We need to check the key element with the middle element. Please keep this in mind and don't make that mistake. So if it is, then the upper bound is fixed, because it lies in the right half, so upper bound is already at the rightmost end. We must change the position of LB to mid +1. LB equals mid +1. Else, if the key element is equal to the middle element, because one of the three things can occur when we compare two numbers, right? Compare two real numbers. Either this number can be greater than this number, or this number can be lesser than this number, or it can be equal. And there are no situations apart from these that can occur. So if these two conditions are invalid, it would suggest that the key element is equal to the mid element. That doesn't require any checking, right? So if it is equal to the mid element, therefore our element has been found, and we assign the index of that element, which is mid, to pos, and we break our loop, because there's no need to search now. Search for the element right now, because the element has already been found. And at the very end, we return the value of pos, which holds the index of the key element, if found. That is. Now, lastly, we're going to write a main method. So public static void main string args. Need to create an object of the scanner class here as well. Let me just create a few things over here. All right, okay. New scanner system in. And the next thing that we need to do is ask the user for the size of the array. System.out.print enter the size of the array. Print size equals sc.next int. After that's done, we need to allocate memory to the array. Allocate memory to the array int arr equal to new int size, and then we take input in the array. Now to take input in the array, we need to call the input method. Now to call the input method, we need to create an object of this class. So let's create an object of this class. Well, I prefer doing things, similar things at the same place. So it's best that I create an object where objects are being created. So obj equal to new. Well, you could very well create an object over here, but I prefer it this way. Now take input in the array. So obj.input, and we send the array. All right. Okay. Next, let us first display the elements in the array. Well, not that. Let's now take the key element. System dot out dot println. Enter the element to be searched. Well, enter the key element to be searched. Huh? Yes, that's fine. Maybe that's not, but you do get the point, like what I'm asking from the user. So sc.nextInt. All right. So before we begin our search, let's first display the contents of the array to the user. So it's easier for us to verify whether the element exists or not. The elements of the array are. I don't need that. Okay. So we can do that by simply calling the display method. ARR. And now we need to call our binary search method. Now, the binary search method, we pass in the array and the key. Now, one of the two things can occur. If the value of pos is -1, that would indicate that the element has not been found. If it is anything other than -1, that would indicate that the element has been found. So, int if pos is equal to -1, it would mean system dot out dot print ln key was not found in the else. Let's copy this. Key was found in the array at position plus pos. That's done. Let's compile no syntax errors. All right, so let's run this program. Okay, so run search. Let's open up. I have an example array. So the size of the array is 8. Element 1, that's -1, -2, 3, 6, 9, 10, 13, 20. Okay. Now the element to be searched, let's say the element that we need to search is 13. 13 was not found in the array. I forgot to change this. I did the same mistake in the linear search video as well. That is what happens when you don't copy without looking. When you copy without looking, was found in the array. The program is correct, just the output statement wasn't correct. Let's run that again. Okay, so the size of the array is 8, -1, -2, 3, 6, 9, 10, 13, 20. We enter the element to be searched. Let that be, let's say, 9. Now 9 was found in the array position 4. Well, it does work. Now let us try to search for an element that does not exist. Perhaps 0. So 8, element 1, -1, -2, 3, 6, 9, 10, 15, 20. Element to be searched at 0, and 0 was not found. That's it. So I hope you have understood the code behind the binary search implementation. Well, do note one thing, that the algorithms of searching and sorting don't really rely on the data type of the array, right? So these algorithms are independent of the data types. That is the reason why if you are asked to run the binary search algorithm on an character array or a double array, the algorithm wouldn't change. In the implementation or in the code, just the data types would change. But that doesn't mean you are going to press Control F and find and replace every occurrence of int to character or double. No. Few things are going to remain int. Like for example, here in this for loop, this will remain int because the index of an array is always an integer. But what would change? The type of the array would change. The method through which we take the input would change, because for a character this would change to sc.nextLine.char@0. For double it would change to sc.nextDouble. This would change, the type of the key would change, but other things would remain the same. So when you are asked to write these algorithms for arrays other than integer arrays, please be a little careful and note that the method wouldn't change. What would change are the data types, right? So I hope you got this. If you didn't, watch it a couple of times. I think it will be clearer for you. All right. So bye bye.